Hi, I'm Isabel. I'm an undergraduate at Minerva Schools at KGI, and I replicated a reproduction of the AlexNet experiment from the seminal ImageNet classification with deep convolutional neural networks paper. The original AlexNet model attempted to classify images from the ImageNet database. It trained on 1.2 million images with 2 GPUs over 5 to 6 days, obtaining correct class error rates of 37.5%, which was considerably better than previous attempts. This paper is credited with motivating research into the use of GPUs and CPUs for deep learning. I used a Kaggle version of the experiment, which applied the AlexNet model to a simplified dataset, the Stanford Dogs Dataset. For this experiment, Chameleon provides the hardware resources. I packaged the experiment with Jupyter Notebook, and then there's Trovy, Chameleon's sharing platform, which allows me to share the final experiment with anyone else who might want to try it. You can also get a DOI from Zenodo through Trovy to include in a paper. In the Jupyter Notebook, you'll see a general structure where first we create an experiment container, reserving the necessary resources from Chameleon. Then we run the experiment using a Python script. And finally, we can visualize the output. This lets us compare the results of our reproduced experiment to the original experiment and see whether we were able to obtain similar results. You can access the notebook by going to Trovy, which is accessible from the top menu bar of the home screen, selecting the experiment you want, and hitting Launch. This will open up in Chameleon's shared Jupyter experiment environment and lets you run experiments on Chameleon while coding in Jupyter. As I mentioned before, the notebook follows the structure of an explanation about the experiment, container setup, and then running the experiment. There's a description above each cell so you can see what it does if you need more explanation, as well as a time estimate. Here, I've pre-run the cells so you can quickly get an idea of the type of output you'd expect. If you want to dive deeper, you can do that by opening each script. This allows you to introduce variation into one part without affecting the other. So if you wanted to change the experiment container part, like the least length, the node type, or even install different libraries, you'd be able to do that without affecting the machine learning part of the experiment. And similarly, if you wanted to change the data set, you could do that without affecting the container. The analysis is all compiled in a separate tab so that you have easy access to all of your images and graphs, and you can just slip them into a presentation or paper. This package is available on Trovy under the Publicly Shared Experiments section. It has an experiment and a Summer 2020 tag, which makes it very easily searchable. If you're interested, this packaged experiment could be used in a class as a module to teach students how to interact with Chameleon, reserve resources, use the Jupyter interface, etc., or as a way to showcase convolutional neural networks, classification, and machine learning in general. And this is really just a starting point for the notebook. You can extend it beyond the reproduction and introduce variation. On the container side, you could experiment with using different types of hardware. And on the machine learning side, you could experiment with adding different layers to the convolutional neural network, or trying it on different data sets, or even introducing your own images. And if you're interested, you can search for other experiments using the Summer 2020 tag. These experiments are all packaged very similarly and are well suited for teaching and learning. Thank you very much.